Hi everyone. In this video we're talking about integral windup and how to avoid it. So and where it is becoming noticeable will be in systems where there is a saturation block. So this is either a valve limit, an amplifier limit, something like that. In reality, systems do have these. So integral windup is something you will see if you don't take precautions. And what it is that imagine you have inputted a set point change to your system. And so because the system's not there yet, you get an error. Well, the proportional term of the controller will respond proportionally to that error. The integral term will respond by adding up the area under this curve, and we'll give an integral response that looks like this. Now, what you will find is normally the integral term would have acted to eliminate the error, but because of this saturation block, it's unable to do so, and some error remains. Because some error remains, this integral term keeps winding up as long as we're not at our set point, which is the case because the amplifier is saturated. So unless we make a set point change, this integrated term is going to keep winding up. Now suppose at some future point you did make a set point change and you said, okay, let the set point go down here. The proportional part of the controller will if we're over here by now, it will respond right away. But the integral part is responding to the area under the curve. So the error has now gone negative, and this is the area under the curve. And the integral term does start coming back, but it has wound itself up so high that it's greatly overshadowing the proportional controller effect. And it's, because it's still making its way back, this this actuator is still saturated at the upper level, and it will remain saturated until this integrator is able to come all the way down, which means the error has to remain negative for even longer until this finally gets below this threshold, and then you'll see a response, and then you'll see a response in the output. So what it would look like on the output is, initially the output responded to the set point with some error, and then after some time there was a set point change, but the output actually stayed the same for quite a while before it finally started coming back. Okay, so how to get around that in a real system? You would, in your let me clear the drawing here. In your integrator term here, the 1 over S part of that, you would attach limits to the internal state of that, and the symbol in MATLAB is something like this, it representing that there are actually internal state limits on that integrator block that prevent it from winding up. You can set a limit wherever your saturator limit is and say, don't let it wind up below the or above this and below, and it will on the positive and negative ends there, and it will adhere to those limits, which means when it's time for it to respond to a change, it hasn't wound itself up. Okay.